All right, so today I'd like to talk about the central limit theorem. This is going to be a really important result for us to use later in the semester when we do hypothesis testing. So I want to start by getting a nice solid foundation in it. And to do that, we're going to start with a statement of the theorem. What the central limit theorem says is that if you randomly select n items from an arbitrary probability distribution, so not necessarily normal, that has a mean of mu and a standard deviation of sigma, then the sample mean, x bar, which you compute by averaging together those n items, that can be thought of as another random variable. So as you select more items, say you do this over and over again, the sample mean will change, and it'll fluctuate around. And if we look at the distribution of all of those sample means, the average, or the mean, will be mu, but because we're averaging things together, the standard deviation will get smaller. And this is what I want to emphasize. So the standard deviation of the sampling distribution is sigma over root n. The other kind of incredible statement that we get from the central limit theorem is that this distribution we get is approximately normal. The larger n is, the more similar this will be to the normal distribution. So much so that our book states when n is greater than or equal to 30, our book says this is the normal distribution. If n is smaller, we can't say much exactly unless the parent distribution is normal, and we'll get to that later in the semester as well. So to demonstrate mostly this first phenomenon, the standard deviation getting smaller by a precise amount, and demonstrating this phenomenon, I found this nice applet online. So I've put a link up on the website for the course, and you should be able to practice this and try this out on your own. So let's load this up. It might take a second. It does use Java, so you might get an error or something pop up, say, do you want to do this? I think it's a pretty safe website. Once you accept, you might have to even update your version of Java. You're going to select Begin over on the left here. And once we do that, I'm going to move it to the center of the screen here. We really don't need that screen anymore. All right, so what we're going to do is here we see the parent distribution. This is that original distribution that we have. And in my picture, I'm actually going to start with the normal distribution. And you can see that by default, the mean is 16 and the standard deviation is 5. And down here, we can choose what n is. And so I'm going to start by having n equal 5. And then we can animate this process. So clicking here, we see 5 items get chosen from this distribution. So by that, we mean they should mostly be chosen from within here, but then occasionally they'll get chosen out there with precisely this probability. Once we've done that, we compute the mean, and that little blue mark drops down, and now we've recorded one sample mean. And then we could do this again. So as you see, we've picked slightly different things. Our sample mean is slightly different. We do this again. We do this again. And again. And after too long, it gets tedious. So we're going to stop doing that. We can, instead of animating it, we can just do it 5, 10, 15. We're now up to 25 reps. Let's do 1,000, 10,000. And as you can see, this distribution is actually not that bad. And what I'd like to really draw your attention to is what happened to the mean. It's still right around 16. And if I go a little further, it should get closer. There it is. And if I look at the standard deviation, it's now smaller. It's 2.24. And if we open up a calculator and we do 5 divided by the square root of 5, we get that's 2.236 or 2.24. So that's precisely what happened for us. If we kick this up to, say, 25, once again, we randomly select 25 things, and they're mostly piled in the middle, but then the occasional one drops outside. We compute its mean. Now, because we're selecting so many things here, they're averaging together, And what do you think is going to happen to this distribution? We do this some more. We do it much more, many, many times. And as you can see, in order for this sample mean to be far away, that would mean that a lot of the data we randomly selected happens to be on this side. And that's just not going to happen randomly. So if we're randomly selecting data here, that averaging effect that takes place results in less movement on the sample mean. And once again, our mean is exactly 16, and our standard deviation went from 5. And if we divide that by the square root of 25, which is also 5, we get 1. So here we have a nice demonstration visually of the central limit theorem. The next thing that the central limit theorem says is that this distribution is approximately normal. Now, if we started with a normal one, that maybe isn't too surprising. But if we start with a uniform distribution, that's certainly not normal at all. And once again, go down and only select 5 things. Now when we randomly select them, they're uniformly distributed on this. So you might think that that means the mean would be uniformly distributed. But this averaging effect does take over. And as we do this more and more, once again we're developing something that looks like the normal distribution. And this is with n just being 5. Our book says that n has to be more than 30. But regardless of what n is, the first part of the theorem is still true. So if we look at the original standard deviation, that's 9.52. If we then divide by 9.52 and we divide by the square root of 5, and there we get 4.2574. And if we hit this a few more times, as you can see, we get 4.25, just like we expected. However, if we look very carefully and fit the normal, so I clicked that button, if we fit the normal distribution in there, you can see it's actually a little bit off. So here, there's some more blue bars sticking out. Here, there's some white space underneath the curve. So you can see it's not quite perfect. But to the naked eye, it actually looks pretty good. If we increase our sample size up to the maximum allowed on this applet, that's 25, now we go ahead and start randomly selecting. And you'll see that we get a much nicer approximation to the normal. Now, while there's a little bit of white, it's on both sides. While there's a little bit of blue sticking out, it's on both sides. This matches much more nicely. And once again, if I take that 9.52 and I divide it by the square root of 25, which is 5, I get 1.904, 1.91. I'm guessing if I hit this enough, I might even get that to go all the way down to 1.90. Because it's rounding up, we're seeing the 1.91, but if you did this, you might get 1.90. It's not happening for me yet. Interesting. All right, so the last thing I want to point out is that this will actually let you also do a custom one. So here you get to pick whichever distribution you want. So maybe you want a funky one like this, but if we select 25 things and we average it, we still get a normal distribution. And when we look at the standard deviation, it still does exactly what the central limit theorem says, 10.52. We divide that by 5, since that's the square root of 25. 2.104, 2.11, that's close enough for me. All right, so I hope this was helpful, and I strongly encourage you to get online and try out this applet, see if you can make good sense of it. Excellent, thank you.